Okay, so now, first of all, let us look at this, okay, how we measure the times and how we actually present the data for the volume. Why 2 decimal places? Why sometimes 1? Why sometimes 2? So this thing actually related to the sensitivity of the apparatus that we use. Sometimes apparatus can allow us to measure very, very precise, very, sensitive apparatus, then allow us to actually read more. Okay, so let us start now. Okay, so now look at this. Okay? We look at the measurements. So always remember, when you measure anything, anything that you measure, you must follow sensitivity of the apparatus. Now, what does this mean? Sensitivity of the apparatus basically means that how sensitive I can read. Okay, so I use a ruler as an example, millimeter ruler. Okay, as an example. So look at this millimeter ruler. This is our normal millimeter ruler. So let's say here is 0. Okay, don't confuse you guys. So here's 0. This 1 millimeter, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So millimeter. So if I have object like I want to measure, let's say until here. I want to measure. So what is the length? So this millimeter ruler actually allow us to read. You can see that, guys. So this is 1 unit, 2 unit, 3 mm, 4 mm. But I can read up to half of the divisions. Cannot. So means that I can read it as 4.5 millimeter. So this is a sensitivity of my millimeter ruler. But can I read 4.3? Cannot. I cannot read 4.1. Okay. Estimate agak-agak. Okay, 4.1. Cannot, because ruler in this case I can read up to half division. So therefore 4.5 millimeter. If let's say I give you another kinds of ruler, 0, 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. So if I have something like this, can you see that? So what is the length? So according to this ruler, I can only read up to half of the divisions. So what's half a division? The sensitivity is this case. 1 division is 2 mm. So divided by 2. So means that I can have the sensitivity of 1 mm. So every time I report, I have to report, let's say, for example, in this case, 5 mm. I cannot put 5.0. If you give me 5.0 means that I can read even 5.1, 5.2. Cannot. In this case, or 5.5, I cannot, because in this case, the sensitivity always half of the smallest division. So in this case, what is the sensitivity? Sensitivity actually equal to half of the smallest divisions, so equal to 0.5. So means that whatever you measure, it must be in the multiple of 0.5. So means that if you give me 4.0, correct. If you give me 4.5, correct. But if you give me 4.3, wrong, it's not multiple of 0.5. If you give me 4, also wrong, because sensitivity is not correct. Because we can read up to 1 decimal point. We can read up to 1 decimal point, okay, and with 0.0 or 0.5. Are you clear? But in this case, in this case, because the sensitivity is 1 mm, so means that I cannot have decimal point. So if give me the length 5 mm, correct. 6 mm, correct. If you give me 5.5, wrong. If give me 5.0, also wrong, because I cannot read until so sensitive. Are you clear? I only can read up to 1 decimal. I only can up to 1 mm, no decimal point at all. Okay. So this thing apply to all measuring apparatus. So it means that when you use a thermometer, okay, let's say for something as for some of these what call these reactions that actually will increase the pH, exothermics, increase the pH, increase the temperature. Okay, so they can measure how fast the temperature increase. Thermometer. So apply again for temperature. Okay, applied to what? Using the burette measuring cylinder. Apply to measuring cylinder, syringe. Okay, applied to the what we call this the burettes. Okay, so those for volume. Applied to what? Okay, you can apply to the mass. Okay, by weighing scale. Okay, for the mass. Okay, so pH. Okay, so you apply, but there is what we call this exemption. I mean the exception case here, but for time different. Okay, because when deal with time, we have what we call the delay in the reaction time. We won't be able to go into so accurate or so sensitive. So time taken when you measure, always remember for all experiment that we have, when you want to measure the time, we always measure in terms of second and must be in whole number. Are you clear? When you measure the times, it must be in second, not minutes. Must be in second. This is the rules, okay, by Cambridge. Okay, we need to follow. Okay, the reason why we don't follow how many decimal point, because of our delay in the reaction time. So that's why we won't be able to get so sensitive. Impossible for us to get so sensitive. So that's why we actually record the whole number. So most of the times you have to understand how to record this. So I have to give you a few examples. So if you use a stopwatch, it shows you 0, 2, 3, 2, 1, 0. So this is minutes. This is second. This is millisecond. Are you clear? Okay, so it means that it's 2 minutes, 32 seconds, and 10 milliseconds. Okay, 32.10 milliseconds in this case. So how you record? So as long as this less than 30, so less than 50, sorry, millisecond, less than 50. Okay, they show less than 50, actually less than 500, okay, in this case, okay? So if less than that, then what we're going to do here is, so 2 multiplied with 60 seconds plus 32. So 120 plus 32. So answer you have to record is 152 seconds. Are you clear? Okay. Now, if you show you that these are stopwatch, so you 0, 2, 3, 2. Okay. For example, here I say 53, for example. Then you have to make sure that you add in another one because more than 50. Okay. So it becomes 2 times 60 plus 33. So answer is 153 seconds. Okay, so always remember 1000 milliseconds equivalent to 1 second. Are you clear? So 553 actually is 530. 53 here is 530 milliseconds. Yeah, guys. Clear? So this is how we record for measurements. Okay, so you can take a photo for this. So once you have the data like this already, you want to present them, okay, in a table. So presentations of the data. Okay, presentation of data in table, and then only we can draw the graph. So when you want to present the data in the table, we have few guidelines here. Okay, so first guideline, you must have a complete table. Okay, number two, okay, so your independent variable, so means that what you determine first. Are you clear? For example, time is your independent variable. Then you measure how much volume you collected. Okay, so independent variable. So independent variable, you must place them either at the top heading or left heading. Are you clear? So I will show you guys what is meant by top heading or left heading, your independent variable. That's one. Second, if you look at independent variable, your independent variable can be either a continuous variable. What's mean continuous variable? Continuous variable means something that you can measure. Then you must have unit at the title there. Okay, so if a discontinuous variable, okay, what's mean discontinuous variable? Something you group them. For example, your independent variable, sample 1, sample 2, sample 3, sample 4. You analyze the sample, or enzyme 1, enzyme 2, enzyme 3, enzyme 4. If these are the variable, there is no intermediate. How you measure enzyme 1, enzyme 2? You can't measure, right? If let's say sample 1, sample 2, can you measure? You can't measure, right? So this one you can't measure. If you can't measure, then no need units. Are you clear? Okay, so this independent variable. So means that if you design the table now, if this is the table, let's say we look at the effect of the temperature onto, let's say, for example, how fast the effect of temperature on the what is it? Rate of reactions, for example, how fast bubble can be formed, for example, or what is the volume. Okay, so let's say first. So you can put your temperature here. And we do know that temperature is something that we can measure, right? So it must have units. So let's say units, in this case, degrees Celsius. Can you see that? And you must have a complete table. So let's say we look at the time taken for the reaction to finish. A time taken. So time taken, always remember, must be in. Sorry, guys. The complete table, can you see that? Time taken in second. So what? Okay. So this is what I mean. So it means that you put your independent variable. What's the independent variable? You want to look at effect of temperature, so must be left heading. Or you can put it as the top heading. Top heading means what? You make a like this. Okay. So you have top heading, temperature, degrees Celsius. Okay, time taken in seconds. Can you see that? So this one is called as a top heading. So you must have a unit. Are you clear? Okay, now next. After you have this independent variable already, number 3, we're going to look at this dependent variable. Means that something that you measure. Are you clear? So determine temperature, right? Just now, you determine the temperature. When determine the temperature, let's say, for example, 10 degrees Celsius, 20 degrees Celsius, 30, 40, 50, 60, for example. So how fast the reaction done? Time taken. So time taken will be a dependent variable. Are you clear? Okay, so dependent variable, again, you need to know whether they are continuous, okay, variable or not. If they're continuous variable, something that you measure, again, you need to include unit must be there. If let's say, for example, you just look at color change, oh, from red to blue, oh, from blue to green, oh, increase in size, decrease in volume. So those are the discontinuous. If discontinuous variable, okay, means that you can't measure, you just observe. Therefore, this one no needs units. Okay, so in this case, I use time taken, right? Can you see that? Where's my pointer? Okay, pointer here. Okay, so time taken. So time taken here means that it's something that can measure. So that's why you need to have the units. Okay, so these are the third one. Number 4, record. So when you record, then you have to check what kind of data you record. So if you record the raw data means that no calculation, you just measure. So this is called raw data. Raw data always follow. Okay, raw data is something that you direct measure the length. Okay, so raw data, always remember, we follow sensitivity. Of apparatus. Okay, so if let's say if I look at my thermometer here, this is 30 degrees Celsius. This is 1, 2, 3, 4, 5, 40 degrees Celsius, for example. So if you look at this, what is the sensitivity? So we look at smallest divisions. Each smallest division is 2 degrees Celsius. So what is the sensitivity? Sensitivity will equal to half of the smallest divisions. So equal to 1 degree Celsius. So means that when I record, I have to record in terms of the multiple of 1. Can I see that? So means that I cannot give 1.5, 1.0. So let's say, for example, I measure the temperature. So at room temperature 35 degrees Celsius. Okay, and then 30, 35, 40, 45, for example. Okay, time taken in this case, I always say that must be in second, and then no decimal point must be whole number. Let's say 25, I take means 100 second. Okay, 30, I take, let's say 50 second. Can you see that? 35, I take 25. Let's say, for example, 40 become 40. Okay, 45 then becomes let's say 70 second. So you can see that this is what I say, that you follow the sensitivity. Are you clear? Sensitivity of data. But sometimes we do have the processed data. So what's the processed data? For example, you calculate the mean. For example, calculates the final minus initial. So this kind of called calculated data. Okay, so in this case, we follow decimal point. We follow decimal point. Okay, now what is mean follow decimal point? Now look at this. If this is my data, okay, temperature, okay, degrees Celsius. Let's say I look at how fast the temperature increase, cause the increase in the length. So I have the length. So length, always remember we measure in millimeter, yeah? Okay, always remember we measure the length. So I have a first reading number 1. I repeat experiment, reading number 2. I get the mean value. Okay, can I see that? So temperature, let's say 30 degrees Celsius, 40 degrees Celsius, 50 degrees Celsius, let's say. So look at the length. Okay, so let's say the first length, let's say 30.5 millimeter. Number 2, 30.0. What is the mean? Anyone calculate the mean for me? Okay, so now in this case, you can see that mean equal to 30.3 because we follow the decimal point. So it means that we're going to round it up to 30.3. Okay, now if let's say time taken, how? Time taken. Let's see. So for example, reading number 1, time taken is 5 seconds. Reading number 2, time taken is 6 seconds. So what is the mean? Right, time taken in second. So in this case, it's not 5.5. It cannot be 5.5 because my raw data, no decimal point, my mean follow no decimal point. So answer mean equal to 6. Okay, mean equal to 6 seconds. Can you see that, guys? So this is what I say, that you follow, okay, the decimal point, raw data, okay, record. So this is what the first part that you need to know. Number 2, must make sure that no unit when you record your data. Can you see that? In my table, can you see that? I don't have units. What for? We have a unit here already, so no need to put unit, everything unit. Can you see that? No need unit. Are you clear? Okay, so record number 2 that we need to know. Record number 3, no calculation. Let's say for min, you don't put your calculation inside the table. Okay, for example, you straight away mention 6. You don't put 5 plus 6 divided by 2, okay, equal to 6. No calculations inside the table. Are you clear? This is number 3. Number 4, applied to the independent variable only. You have to make sure that when you record the independent variable, it must be either in the ascending order or descending order. Follow question. Now, what's mean? Sometimes question asks you to start with the higher temperature first, then you record in the descending order. If the question asks you to start from the lowest temperature first, then you record it as ascending order. So what's mean ascending, descending? Can you see that, guys? In my table here, this is what we call that ascending order, because I start from the lowest temperature to highest temperature. But sometimes question asks you, okay, start from 45 degrees Celsius highest, then you record 45, 40, 35, 30, 25. So it must be in order. You cannot say, okay, I start with the 45, then the next, I want 40. I have to put 40. Oh, the next one, I want 25. Cannot. It must be in order for the independent variable. Are you clear? Okay. So this is how we present the data. Okay. So you can copy down presentation. So I put it part by part. Okay. So part 1, 2, and 3. Take a photo. Okay, this one we're going to actually practice it when you come to the practical. So this is the practical slot today. Oops, too bad that I can't actually continue with the graph. I don't have time.